Okay, welcome everyone. I'm so excited for our guest today. You're going to love hearing from her. This is Sarah Powell joining us from Texas. Just a little background about her. She's an associate professor at the Department of Special Education at the University of Texas at Austin. Her research interests include developing and testing interventions for students with mathematic difficulties, with a special emphasis on peer tutoring, word problem solving, mathematics writing, and the symbols and vocabulary within mathematics. She's currently an investigator of topics such as kindergarten math, word problem solving, and middle school math. In addition, she was awarded a doctoral leadership grant, which we will talk about towards the end of our discussion today. Welcome, Sarah. I'm so glad you're here with us.
Oh, thank you so much, Adrianne and Heather. It's really nice to be here today.
Yes, we're so glad to have you. And we had Heather Brand from the Made for Math team join us today. She
Yay.
seriously loves word problem solving. It seemed inappropriate not to have her join us. So we're excited to have both of you join us here today. And we're going to talk about all of the fun things around math, language, and vocabulary, and those word problems. So let's just dive right into it.
All right, sounds
So,
great.
what are some important considerations regarding like math language and the vocabulary that we see when we're teaching students?
Yeah, that's a really good question. So I think the first thing is to think about with math language. I would say math language is all the ways that students interact with mathematics. So we often think about that as numbers and symbols and words, but also all the visuals and all of the ways that students use bar models or graphic organizers or number lines. All of that is a language in which we communicate in mathematics. And I think people would even say manipulatives and virtual tools are also part of that math language. But one of the things that I've really focused on is math vocabulary, which is a part of math language. And there are hundreds of math vocabulary terms that students really need to know at any grade level in order to be a full participant in the math classroom. And so we've been working a lot on what are those terms, what are the difficulties that students might have with those terms, and then what are some of the ways that we could support students in the learning of that math vocabulary so that they fully understand that language of math.
I think it's so fantastic. And what's unique about the math vocabulary and the language of mathematics, it's mostly spoken at school. It's not
Yes.
necessarily spoken in the home. And so it makes it particularly tricky to teach it.
It
Um,
does.
yeah.
Yeah, there's a lot of terms that students would never hear until they step foot in the math classroom or come to math tutoring. And so those would be terms that we need to explicitly introduce to students and practice a lot. But there's also a lot of math vocabulary that students know the term because they hear it in what I'll think about as general English or like outside of the math classroom. For example, bass. They might think about like baseball or bass guitar or a military bass, but then there's also meanings of the word bass in mathematics. And so, because of many times this double, triple, quadruple use of the same term to have lots of different meanings in math and outside of math, that can also be really confusing for students as well.
Oh, I totally agree. So why are these considerations so important in math intervention, like especially for students that have dyslexia or dyscalculia?
Yeah, that's a really good question. Well, I see that that language of math, particularly math vocabulary, is really how students interact with math, whether they're reading in math, doing writing, and they have to spell these math terms, but they're also hearing all of these terms. And if you don't know what numerator is, or if you don't understand what a trapezoid is, just by hearing that term or by reading that term, it's going to be really hard for you to be successful in mathematics. So, and that probably is particularly difficult for students like the students they were talking about, maybe students with dyslexia or dyscalculia, maybe students that are multilingual learners. And so they're not only learning English math, but they are also learning a home language and maybe some of the math language that's associated with their home language. And maybe students that have speech or language difficulties, those students likely need additional supports beyond other students related to the learning of that math vocabulary.
Yeah, absolutely. So I'm curious, what kinds of things do you recommend for those outlier type students?
Yeah, this is a really good question too, Adrienne. So I work on a project with one of my colleagues, Liz Stevens, at the University of Kansas, where we are right now developing materials that students and teachers are using in schools today and throughout this year to figure out what are some of those best ways to support math vocabulary. Because I think a lot of people would agree that math vocabulary is really important, but we're just getting to the point where research is trying to investigate what are some of the better pathways for the support of that math vocabulary. So, some of the things that we're doing right now, and we may learn that they're helpful. We also may learn that better things are helpful. We're doing a lot of what we call concept maps with students. So, if we're thinking about a term, maybe the term is numerator. And so there's a concept map. It's a one-page concept map that the students get a copy of, where it has the term, a student-friendly definition, some visuals and explanations that go along with what does numerator mean. And then there's also a section around related language. So if you're talking about numerator, you're probably talking about denominator. If you're talking about numerator, you're also probably saying the word fraction. You might also be talking about parts of a whole or equal parts of a whole. And so what we've learned is that every vocabulary term has a lot of this related vocabulary that you also have to understand in order to understand that term. So we're doing concept maps. And then right now we're also doing a lot of different, I'll say, games and activities to help students practice those terms. So we're doing like uh, like a game where you hold up the term on your forehead and I don't see it, and then you have to describe it to me, and I have to guess that the term is numerator. We're doing some memory matching games, and we're doing other activities. So the teacher introduces the term with the concept map, but then the activities get into that practice. Because
Oh,
I
I
think, as
love
we
it.
all would agree in math, practice is really how you learn things. And that's not only true for math concepts and procedures, but that also is going to be true for math vocabulary.
I
So
love
stay
that.
tuned. Yeah.
Yes, yes, I'm
Yeah.
super excited to hear about that. One of the
Yeah. We're
games
very
that
excited about that project. Yeah.
one of the games that we like to play is we'll do like guess my number. But what we
Hmm.
like about that game is it's so flexible and
Yeah.
it allows students to actually practice it. So even like a higher concept, you could put a variable in there and have them practice saying things
Yeah.
like that. If it's
Yeah.
like a
Agreed.
square and it's like, does your number have an exponent? And now they have
Hmm.
to understand, what do these numbers look like that have exponents, right?
Yeah.
So
Yeah. Exactly.
yeah, that's super fun.
Yeah.
So let's dig into the word problems part, because
Okay.
we at Made for Math have kind of deep dived into Dr. Chin's approach
Hmm.
with her schema-based instruction. And so we really like that. So we know that you have a lot to say about schemas too. So where do schemas
I do.
come from?
That's a good question. Well, schemas are really not related to word problem solving. It's really how students interpret the operations. And so there's a lot of work that's decades old that has observed how students add, subtract, multiply, and divide, and also dug into what are the ways that students should understand addition, subtraction, multiplication, and division. So for example, with addition, when we think about adding, we'll say 4 plus 3, I could think about that as these parts that are put together for a total. So that's one way that students would think about addition. But students could also think about addition as adding on. So I start with 4 and I add 3 more. So that's just how we think about the operations. But then that is directly related to the word problems that students are asked to set up and solve. So students will see word problems where they're asked to put parts together for a total. Then they also will see word problems where they start with amount and something happens to increase that amount. So that early understanding of what does it mean to add, subtract, multiply, and divide is then eventually directly related to word problems. And that connection starts early, even if teachers don't think they're supporting word problems. If you are using hands-on tools or virtual tools to help students understand putting these amounts together for a total. So you might say, oh, we've got, 4 blue cubes and 3 red cubes. Let's put those together for a total. And then you could say, oh, what if you have 4 blue cars and 3 red cars. How many cars do you have altogether for a total? That is early problem solving, and you're laying the groundwork for later, more formal word problem solving.
Yeah, absolutely. So, can you tell us a little bit more about the work that you and your team are doing with word problems?
Yeah, we've been doing a lot of work with word problems just because they're really important for students to be able to approach and solve successfully, but they're also really tricky for students. And in fact, when we look at state level data at every state in the United States, we see that pretty much the majority of students in the United States don't meet what would be considered a minimum level of math proficiency on their
Mhm.
state assessment. And that state assessment is almost always a bunch of word problems. So
Yeah.
we know that the word problem solving is a barrier for many students in terms of showing off what they know about math. So before COVID, I'll say from 2015 to 2020, my team was doing a lot of work at grade 3, where we were taking a word problem intervention that was originally developed by Lynn Fuchs and colleagues at Vanderbilt University called Pirate Math, and we were investigating a new version of that called Pirate Math Equation Quest, where we were really wanting to understand how students use equations to represent the structures or the schemas of these word problems, and then what would be some of the supports necessary for students to use those equations to solve word problems. So, for example, if I have a word problem that's like Adrianne and Heather have 10 pets. If Adrianne has 6, how many pets does Heather have? You could use an equation like 6 plus blank equals 10 to represent the structure. So you're given the total and one of the parts, and your job is to figure out another part in that situation. But if students have a hard time generating 6 plus blank equals 10, or I would say solving 6 plus blank equals 10, then they wouldn't be successful in solving the word problem. So we worked a lot on that program. We learned that was very helpful for students in terms of increasing word problem knowledge. And so then from 2020 to current day, we've been working on a grade 4 version of Pirate Math Equation Quest. We've just finished the big study around it. We are seeing that the program is very helpful for improving student word problem outcomes. And with that version, moving to grade 4, not only are we working on single step word problems, but we're also working on multi step word problems, which we start to
Mm.
see a lot of, a little bit in grade 3, but a lot more in grades 4 and 5. And so in many of those problems, you have multi schema problems. So first, you might be asked to figure out the total, then you have to do a difference schema. Or in many word problems, we see first you use this equal group schema, and then there might be a change to that schema. So we're trying to help students think about how do you attack these multi-schema, multi-step word problems, which they're going to see a lot more of in the upcoming years.
Oh, I love that. So
Yeah,
the
it's very
website
fun.
that you mentioned, the Pirate Math Equations, is it
Yeah.
available to the public for free or is it
Yeah.
paid access?
Yes. Yeah. So our website for the program is piratemathequationquest.com. And there are several different programs that we've investigated. Most people are really interested in the small group tutoring program. So they can click on there's 3 little pirate kids there. You can click on the little pirate kids, and then they have free access to all the lesson guides, all of the student materials, and all of the teacher materials. So if they were interested in implementing that intervention as we designed it, all of those materials are there. We also know that a lot of teachers access the materials and then use them in slightly different amended ways for their classroom. So we have hundreds of word problem cards. Many times teachers will say, I need more word problems to practice. Well, we've got hundreds of cards that you can download for free. And then there's also a lot of different student materials that can be used in the classroom to support the word problem solving of students.
I love that.
Yeah,
I'm
yeah.
so excited you've been working on that.
Yeah, the new multi-step version is mostly finished. We're still just doing a lot of last minute edits and checks to that before it will be freely available on the same website, hopefully by the end of 2024.
Awesome.
Yeah.
That's really exciting. So another thing that we've noticed is that you include hand gestures. Can
We
you
do.
show
I was
us
already
some of
using
those?
them. Yeah. 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 So as we talk about schemas, um, let me go back. Okay, so we read a word problem with the students. And that's an important part right there. First of all, a lot of students don't read these word problems before they start doing stuff. I'm sure both of you
Yes.
have seen that. Um, the second thing is that, so we read them together, like do a read aloud, or maybe the adult reads to the students, but often you want the students reading these word problems with you. And then you want to think about, well, what's going on in this story? Is this story about pets? Is this story about sharks? Is this story about money? And then what's going on in this story? Oh, are we, putting things together? Is there a change? That type of thing. So once students have read it and briefly discussed it with adults or other peers, then we have some questions that we ask students to help them focus on the schema of the word problem. Schema just means the conceptual meaning of the word
Mhm.
problem. And so we pair those verbally presented questions with a gesture. So I'll do that right now. So I would say, is this a total problem? Are parts put together for a total? Is this a difference problem? Are amounts compared for a difference? Is this a change problem? Does one amount increase or decrease to a new amount? Is this an equal group story? Are there groups with an equal number in each of those groups? Or is this a set story? Is there a set compared a number of times? So
Ooh,
we use those gestures, and students really latch on to the gestures.
yeah.
Maybe if it's like an equal group story, they're like, no, because I have boxes and there's the same number of donuts in each
Yeah.
box. And so it ends up, we ask students, what's the, what type of problem is this? That's the question we ask. And many times they'll just use gestures. They'll just say, like, they don't even say it out loud. And so if they do hold their hands apart and put their hands together, then I know that they're talking about a total problem.
I love that.
Yeah, yeah,
Makes my heart very
yeah.
happy. We're big fans of
Do you
gestures.
all use similar gestures or do you have different gestures?
Yes,
Yeah.
yes.
And you have these videos available online walking through the schemas and the gestures, right?
Yeah, yeah, yeah. We have videos on the Math Equation Quest website about the gestures. You can also find me and some of my colleagues doing the gestures on other websites because we've recorded that many times, knowing that people would like to have gestures that go along with the word problem schemas.
I love that.
Yeah.
Awesome. Okay, so now that we've talked about the math language and word problems, so what are some examples of accurate math language when working on story problems? I heard a few cute things and I'm like, yes, I agree.
Yeah,
I'm
yeah.
curious, like, can you spell it out for us that
Yeah,
are listening?
yeah, so one of the things that I just somewhat did a demonstration of is that we are very consistent in how we talk about these problems. So in the elementary grades, K to 2, there are three schemas that students will see regularly. So that's total, difference, and change. And then starting in grade 3, the equal groups and the set schemas come into play. Some people call set multiplicative comparison. We just have call those set problems. It's a little bit easier for kids to say and kids to remember. Those come into play in grade 3, and then they continue with students through the rest of their career. So students in grades 3, 4, 5 will see those 5 schemas: total, difference, change, equal groups, and set. So as we talk about them, every time we talk about them, we use the same language. So just as an example, with total problems, it's always parts put together for a total. One of the things that we never say is two parts put together for a total, because many total problems actually have more than two parts. Sometimes you make an assumption that it's two parts, particularly when I'm using the gesture, because I only have two hands and I'm putting them together for a total, but
Yeah.
many total problems are 3, 4, 5 part total problems. And so just for total problems, I would always ask, is this a total problem? Are parts put together for a total? And then once students decide that it is a total problem, and we're filling in either a total equation or a total graphic organizer to represent the information from that total problem, I always ask, does this number represent one of the parts or the total? Like every time I say it that way, so that students start to hear that consistent language and they always think parts put together for a total. Same thing with difference problems: greater amount, lesser amount, they're compared for a difference. Is this the greater amount? Is this the lesser amount? Or is this the difference? For change problems, we always talk about a start that increases or decreases to a new amount. And so there I could be like, does this tell me about the start, the change, or the end? So as you think about introducing these schemas, I'm not been keeping track, but I've probably introduced 20 at a minimum vocabulary terms that are really important for describing these word problems. But also what's really important is using that language very consistently. So students always think about equal group stories as groups with this equal number in each group, or this set that's compared a number of times. So consistency is key, not only from the teacher, but also from the students, getting them to talk about, oh, I've got these groups with an equal number in each group, and they compare that with a gesture to help put some meaning with that. So that's one big idea around language related to word problem solving. The other big idea, which I will say is a big no-no, is really focusing on keywords and tying those keywords to operations. So focusing on keywords like total, altogether, per, share, each, more than, less than, a lot of these terms that we'll see regularly in word problem solving. Focusing on keywords is important. You are going to talk about what those words mean or those terms mean in those word problems. And a lot of times they're going to tell you about the meaning of the word problem. But what we don't want to do is say, oh, whenever you see total in a word problem, that means you add. Or whenever you see share in a word problem, that means you divide. There's no time where one word always means the same operation. And in fact, the people that put together word problems, particularly for state assessments, they know that kids think, oh, whenever you see total, that means you add. But often when students do see the word total in a word problem, maybe they end up subtracting, maybe they end up multiplying, or even maybe they end up dividing. And so, not a lot, but some teachers have what I would consider these keyword posters in their classrooms where terms are organized by operation. And so then kids just pluck a word out of the word problem. They look at the poster and they say, oh, this word problem has less than. That means I should subtract. But that is not what you often end up doing to solve the problem. So I would really describe that keyword strategy, linking it to those operations as a totally ineffective strategy. It spectacularly falls apart for multi-step word problem solving. And so, but instead, if you see less than in a word problem, what does it mean if Heather has less than Adrianne? Let's talk about that. And then usually that can cue us into, well, if Heather has less than Adrianne, we're actually in a difference problem. And I might add, I might subtract to solve that problem. The operation is really secondary. The deeper meaning of that word problem, or the primary thing that we want to focus on, is the schema, conceptually what's going on in this story.
Oh,
That was a long-winded response, but I'm really don't want people using the keyword strategy
mhm.
tied to operations, so I think it's important to talk about.
So with that, I guess I'm curious, what do you think would be a better solution? I know teachers love their posters and
Yeah, yeah,
strategies because
yeah.
they are kind of like a cheat sheet, a
Yes,
reference
yeah,
point,
yeah.
right? So what would you recommend they do instead, if they wanted to create some sort of visual like that?
Yeah. So a poster like that, a keyword poster, those terms are great terms. So have those on your word wall, make a word wall in the classroom or make student glossaries, but don't organize them by operation because there's no time where total always means to add. So I think word wall stuff is really great, or other vocabulary ideas or activities would be really helpful there. And so I should talk about more than and less than. What does it mean if I have fewer? But there's also, I will say, there's a lot of word problems that don't have any of these math keywords in them.
Yeah.
This is particularly true for change word problems where you have a start amount that increases or decreases to a new amount. many times the words there are not even math words at all. So maybe there's a question that the temperature is warmer one place than another. Maybe I have a river that's longer. You have a river that's shorter. Most people wouldn't say that longer is a math key word, but it is a word that tells you about the comparison between two things. And then also a lot of change things, maybe if well, those were some different examples, but in change things, maybe I bought something, maybe you gave me something. That's really cueing you into the change. And I don't think that a lot of people would say gave is a keyword or lost is a keyword. But those really do cue you into the meaning of that word problem. And we also run into quite a few released items from standardized tests that have no keyword in them at all. Or in a lot of multi-step problems, you might find 4 keywords. And so then the question is, which one of these should I pay attention to? Well, you really need to pay attention to all of them. But if you have a deeper meaning of the word problem related to the schemas, that's going to help you with that. So the two things that do have a really strong evidence base to support their use when it comes to problem solving, the first is the use of an attack strategy. So these are strategies like many teachers use R cubes, where they read the problem first and then they do some things to help students solve the problem. Solve is another really good attack strategy. Students study the problem, they organize the information, they line up a plan, they verify their plan, and they examine their answer. So that's SOLVE. And then the attack strategy we use most often is UPS check. So students understand the problem, make a plan, solve, and check their work. So attack strategy, which other people call a metacognitive strategy, really helpful for just understanding what do I do first? What do I do second, third, fourth? How can I work through this word problem? Or how can I attack it? That's why I think about attack strategies. Then you pair that attack strategy with a focus on those word problem schemas. So in this story, is it a total story? Are parts put together for a total? Is it a different story? Are amounts compared? Is it a change story? Does one amount increase or decrease? And then equal groups and set can follow after that. So if you take that attack strategy and combine it with a focus on the schema, those are really the two strongest research validated practices currently in the world of word problem solving. So those would be the two things that I would suggest for teachers to do. And you do them
I
at the
love
same
that.
time. Yeah.
Yes, perfect. One thing that popped into my mind is some listening to us might say, like, well, Sarah, you're just teaching to the test. Like, you're just
Yeah.
teaching
Yeah.
kids how to.
Yeah.
So, what would you say to the naysayers in that situation?
That's a great question. Well, some of it is, can students set up and solve these word problems for a chapter test, unit test, a high stakes assessment? And until we change things drastically in the United States in terms of how math is assessed, students have to set up and solve word problems to demonstrate their math knowledge. So I think those are just the parameters that we work with in the United States, and I would suggest in most countries in the world. So if we
Mhm.
want students to show off what they know about math, they better be able to set up and solve word problems. But also, students are solving word problems, maybe not formally, but pretty much all of the time in their lives as they are going out and as they will get jobs or if they will have careers. You are often putting things together for a total. You are often grouping things where you have groups with an equal number in each group. So you might say, if I need to buy 30 cookies and they're packaged in packages of 6, how many packages do I need to buy? That's an equal group story. And, probably some of your listeners have done that in the last few months, like figured out how many of these packages do I need to buy to have enough things for this birthday party or for my classroom. And so the schemas really stick with you throughout adulthood. I would guess that everybody's used at least one of those 5 schemas in
Mhm.
the last day or so, but maybe haven't thought about it. And so while I'm talking about word problem solving that is somewhat classroom based, there's a lot of transfer of those schemas to how we interact with math in the real world.
I agree. I think it really teaches kids to think critically because
Yeah.
you think maybe you understand the context of what's going on, and then as you think about it deeply, you realize, oh, there's some pieces that I didn't quite grasp. And I
Yes.
think
Yeah.
that translates to a lot of situations. And
Hmm.
it can be a
Agreed.
really powerful tool.
Yeah.
Okay.
I mean, what are some of the things that you all do to support word problem solving? Are you using attack strategies? And it sounds like you're focusing on the schemas, but what have you found to be successful for supporting your learners?
I would love to have Heather answer this one because she has been working so hard on it.
Yeah,
Well, when you talked about attack strategies, we ended up creating one because the students
great.
we work with tend to need more of those steps in between the other.
Yeah, I could see that.
So we use one called Romans. And so the first one is reading and highlighting and not highlighting for keywords like you
Yes. Yeah, just like what's the key information? Yeah.
that help you choose a schema. And then intentionally, O is the next one for organize. They have to organize it in their mind before they make an equation. So maybe it's a graphic organizer with part total,
Love
things like
it.
they've got to organize it. Maybe it's a picture in some way before they can make the equation. So M is make an equation.
Okay,
Graphic organizers for that to choose from to help our students.
that's cool.
A is answer and label because they
Okay.
struggle with choosing the right label, especially if
Yes.
it's duplicative.
Yep.
Knowing, is this the set or is this the multiplier? Things like that, right?
Yeah.
So, ROMA, answer and label. So N is need to check,
Okay.
and S is sentence because that's something we specifically
Ah, nice.
students. And we
Yeah.
have to break down the language, like what are the parts of a sentence? You have a who or a what and a what's happening. So if we're comparing, for example, who did the question actually want to know about? Did it want to know about Adrianne's pets or did it want to know about Heather's pets?
Yeah.
And
Yeah.
then the what's happening part and making sure that your actual answer ended up in there. Because I've seen too that if we had a missing add end, they get all the way to the end and then they put the total as the answer.
Yes. Yeah.
Break it down a little bit more for our kids who tend to skip some of those little steps in between.
That's great. I love Romans. I was just in Australia last week working with some teachers on word problem solving, and one of the groups, they've created their own, it was rucksack. And so I think that's like find an attack strategy that works for the learners that you are supporting. But all the attack strategies that we're talking about involve reading the problem first, which is one of the things that students often want to skip and they just start doing stuff instead of reading and understanding. And so I like that, Romans. That's really great. I might share that with some other people. Yeah. As you were talking about that, Heather, you bring up this whole thing kind of going back to vocabulary and language of just how much vocabulary is in these word problems. We did a count in our state. I live in Texas, but your average word problem at grades 3, 4, 5, I have to remember, but students either have to read 23 or 27 words for a single word problem. And then if students have to do that 30 times, it just the amount of reading students have to do is quite staggering. And not only
Mhm.
reading, but understanding of that language. But then there are all of these situations where the units and the problems can be confusing for students. So like we can talk about, oh, if you have cats and dogs, but the question asks about pets. So students have to understand these different that's like a superordinate category of pets, and then that relates to cats and dogs. But I love the example you also bring up with equal group stories, where I might be talking about these boxes and each box has donuts, or I have these packages and each package has light bulbs. So my unit for the answer, is it about light bulbs or is it about the packages of light bulbs?
Mhm.
And so you have to have a lot of discussion and just a lot of practice identifying these different units, because yeah, students will say, oh, the question is about light bulbs. It's not actually about the light bulbs. It's about the packages of those light bulbs or about the donuts that are within that box. So, I mean, the language of math, but just language in general, um, is something that adds that layer of complexity to word problem solving that we just have to think about how to support in the classroom.
Well, and I think you've made a tremendous amount of supports that are available free online. And so you mentioned the pirate math. What other ones could you share with us?
Yeah, so it's me, but I have an amazing team that supports me in a lot of these efforts. So yeah, we have all of our word problem materials and videos at piratemathequationquest.com. We also have a teacher support project called Math Spiral. So that's mathspiral.com. That is designed for teachers at grades 3, 4, 5, but I think other teachers and caregivers and other supporters of math might find some stuff helpful. So if you visit that website, we have free and downloadable UPS check posters. We have free and downloadable schema posters. There's a bunch of videos about word problem solving there. We also have free and downloadable word wall glossaries, word wall cards in both
Mm.
English and Spanish. We also have
Ooh, yeah.
glossaries for students in both English and Spanish that are free and downloadable. We have 10 ways to practice math vocabulary. Then there's also a bunch of other stuff on that website about use of manipulatives for helping students understand math, how to build fluency with facts and other things in mathematics, as well as how to teach explicitly and that type of thing. So you can do that. And then we also make a lot of videos for another project that I support in middle school called Project Stare. So we have a YouTube channel for that, which has probably over 200 videos at this point of how do you use two color counters to help students understand subtraction of fractions with unlike denominators. So it's very specific, but very brief videos. So if you are a teacher and you want to use fraction tiles to help students understand multiplication of fractions, we've made a video of that, usually less than 5 minutes, to just give insight as to what is important in terms of not only the conceptual and procedural knowledge, but also the language of using those fraction tiles to multiply those fractions.
I'm so excited to dig
Yeah,
in and share those things. You're doing such great work. And you've
thank
talked
you.
about a lot of
We're
those
actually
projects.
recording in the recording studio today. We've got a teacher request for more videos about word problems where students are multiplying a fraction times a fraction. So I'll be in there later today
Ooh,
making some of those videos. Yeah. And then
excellent.
they'll soon be on the, I think those go on the Math Spiral website. Yeah.
Okay, great. We'll watch for those.
Yeah.
So, the last thing I would love to chat more about with you, because there's just so much we could learn from you. And I bet others that are watching are curious about this too. So,
Yeah.
you have this 4-year doctoral leadership program at UT Austin. Can you tell us
Yes.
more about that program?
Yeah, so currently I have with my colleagues Erica Lemke at the University of Missouri and Leanne Geller, who's at SMU in Dallas, Southern Methodist University. We do have a doctoral training grant that's funded by OSEP, which is the Office of Special Education Programs. And there with that program, which is called LIME, we are supporting 12 PhD level students in terms of their PhD program. And so they participate in their PhD program at their university, but they also do some LIME activities that are really focused on math and math intervention and math and special education and what are some of the ways that we can support those learners. We also have another doctoral training grant that runs here at the University of Texas at Austin and 6 other universities that's supporting learners that are interested in comorbid issues related to disability. So the student not only struggles with math, but they also struggle with language. So there are I'll say dozens. I hope that is a good approximation. There are dozens of these doctoral training programs out there. Lyme and the other program that I was talking about, which is the NCLII, are just two that are hosted here at UT Austin, but there's others here at UT Austin, as well as others at many universities across the United States. But the idea is that OSEP, that Office of Special Ed Programs, is providing funding to universities so that people can come and do their PhD, and then when they graduate, they go out back into the world and they conduct research and they do teaching in the area of special education to try to improve the outcomes for students with disabilities. So we have one of those, but there are also a lot of funding opportunities for people to do their PhD program outside of those specialized programs. So for example, if people come do their PhD here at the University of Texas at Austin, we have teaching assistant positions and research assistant positions that allow you to get a stipend, and then all of your tuition is paid for and your health insurance is paid for. And then you get that experience during your PhD program. So maybe you're out
Mm.
in schools working on one of our word problem interventions, or maybe you're supporting teachers here at the university, especially our pre-service teachers as they go out and they need people to do observations and give feedback to them as they learn to be a teacher. And so I would suggest, particularly in special education in the United States, that there is likely a PhD program that wants to recruit you and pay you to do that PhD program. And so at least 100% of my students graduate with zero debt. And then they go out and do their own thing in the world, which is really important for both teachers and students. Yeah.
Amazing and
It
very
is. Yeah.
tempting.
Yeah, there's a caveat, especially here at UT Austin and with most PhD programs, is that they are very location based. So I live here in Austin, Texas. All the research that we conduct in schools is in the Austin, Texas area. And I would suggest in a PhD program, the experiences doing research are as important, if not more important, in the coursework that you take. And so all of our students are in schools pretty much on a daily basis learning how to collect data, analyze data, work with teachers, work with students so that they have that hands-on experience and then they can go on and do research outside of their PhD program eventually. So most PhD programs do require you to move to that location and be there for a short amount of time while you not only take your courses but participate in that research or that teaching. There are, I think, a few online PhD programs, but I know there's more online EDD programs. So if people are not movable, then I would suggest looking into that. But right now, and probably for the next decade or so, I think we're still going to see very location-driven PhD
Mhm.
programs, particularly if you want to be doing that work in schools on a daily basis.
Oh, I love
Yeah.
that. And I thank you for anticipating what I was going to ask about
Yeah, I know.
online.
It's like it's super hard because I talk to so many teachers because I get to travel not only the United States but the world, and they're like, "Oh, I'd love to do a PhD with you." And my first question is always like, "Are you movable to Austin, Texas for at least 3 to 4 years?" But the good news is wherever people live, there's usually a university somewhat nearby
Mhm.
that probably does have a good PhD program or an EDD program or a master's program if people are just trying to pursue their master's degree where they could access that locally. So I would suggest reaching out. If you live in Kansas, talk to Kansas State or the University of Kansas. If you live in Missouri, talk to the University of Missouri and many other universities there. And many times, just reaching out and starting to ask some questions would be a good first start. And then people at those universities might be able to tell you, oh, go over to St. Louis. They have this great program there that you can access.
Love it.
Yeah.
Okay, one last thing. You talked about recently about a master's program
Yeah.
that you guys are looking at developing. Do you have more information about that?
Yeah, I don't have that much information about that, but at the University of Texas at Austin, next year we are putting together an online master's program that's going to be focused on dyslexia and dyscalculia. And
Awesome.
I am not in charge of that, so I know very little. But there are people that are working on making that a reality right now. And I do think there are more online master's programs available
Agreed.
than there are online PhD programs. So that's a good first step. And then if you do a master's degree and you're like, I love this and I want to learn more about how to design interventions for kids who struggle with math, then that's where a PhD program could come into play.
Love it.
Yeah.
Oh, I could just talk all day about
Me
all of
too.
these things.
I love geeking out and thinking about math and also thinking about getting more people to support math. Many schools have quite a few reading specialists or reading coaches, and I would suggest we need as many, if not more, math specialists and math coaches and people who are doing math research and leading the conversations in math. There's a lot of us, but there's not as many of us as there are research questions. There's still so much we need to learn in terms of the support of students, especially when students have math difficulties. So I would really encourage people, if they have a passion for it, to try to follow that passion.
Love it. Thank you for sharing all of that today. As you know, we like to wrap up with dorky math puns and jokes. Do you have one you want to share with us?
You know, you asked me about a math pun or a math joke, and I hear a lot of them, but I didn't look up one. But
That's okay.
I have a dorky math story I think I'll tell you. So I do a lot of work on the equal sign, and that was my whole dissertation. And my sister recently was telling me this story about my mom. So I was out on some road trip talking to teachers about math, and evidently my sister was talking to my mom, and it's like, "Oh, Sarah's in Kansas this week." And my mom's like, "Is she still talking about the equal sign?" And I was like, "Thanks, Mom." You know, like, the equal sign is important. Students misinterpret it. But yeah, so I think my parents only think I talk about the equal sign, but I do talk about more than that in math. So that always makes me laugh. And my sister and I always laugh about how my mom just says that. So it's funny. Yeah.
I love that. I think
Yeah.
that's hilarious.
Yeah.
Well, lastly, where can people connect with you if they have more questions about all the things we
Yeah.
talked about?
Pretty easy to find on the internet. I'm Sarah Powell at the University of Texas. You can look me up and probably find my faculty page pretty quickly. But they can email me and or reach out to me on social media, where I just share a lot of things about math. So I'm sure you will put my connection
I sure
information
will.
on this podcast. So yeah, but feel free to email. I will respond to everyone's email, but sometimes I get a lot of emails. So I might be at a 24 or 48-hour turnaround, but I will respond because I love talking about math and the ways that we can support the math learning of students in better ways.
Awesome. Well, thank you so much for being here and
Thank you for
joining
the
us on
opportunity.
this.
Yeah, it was really nice to chat with both of you today.